Okay. Hello. We're going to go over a couple of sections in Math 097. And the first section is R4 in our textbook, and it is entitled Simplifying Algebraic Expressions.
Are you on?
All right. First of all, what differentiates a course in basic algebra versus basic mathematics is something called a variable. Okay. And what is a variable? Basically, a variable is just a letter. And most common variables that are used in early algebra are like x's, y's, maybe z's, a, b, n. Okay, but any letter could be a variable. Nice thing about a variable is that it can be assigned any numeric value. For instance, I could let x be equal to 3, or I could change my mind and let x be equal to like -5. Okay. So a variable could be assigned any numeric value. All right. What is an algebraic expression? Well, an algebraic expression is an expression that contains one or more variables. For instance, this is an example of an algebraic expression, 2x, with the understanding that it's 2 times x. Okay. Now, we say that the 2 here being multiplied by x is called the coefficient of this term. The x is called the variable part. All right. Another example of an algebraic or variable expression would be -3x squared y. -3 times x squared times y. The coefficient of which would be -3, and the variable part would be x squared y. Algebraic expressions don't only have to have one term like these are. These are called one-term algebraic expressions. Sometimes your algebraic expressions could have multiple terms, but terms are always separated by additions or subtractions. Here's an example of an algebraic expression. It contains 3 terms, this term, and this term. Notice terms are separated by additions or subtractions. This is an example of an algebraic expression. Here's an example of an algebraic expression. Okay. What would be the coefficient in front of the first term of this algebraic expression? Well, you just see a negative sign in front of the x. But when you just see a negative sign in front of a variable, it's really understood that it's like -1 times that variable. Understood. Okay, so -x is really the same thing as -1 times x or -1x. These are all examples of algebraic expressions. What we're going to learn how to do in this section is we're going to learn how to simplify an algebraic expression. But before we do that, we need to introduce ourselves to what are like terms in algebra. Like terms. Like terms are algebraic expressions with the same variable parts. Those are called like terms. Here's examples of like terms. 2x and 3x are called like terms because they both have x for the variable part. Negative 5y versus 1/2 y are like terms because they have the same variable parts. Negative x squared z is a like term with 11x squared z. These are called like terms because they both have the same variable parts. So like terms are algebraic expressions with the same variable parts. Some examples of unlike terms then should be simple to come up with. These would be terms that do not have the same variable parts. For instance, 2x is not a like term with 2y because their variable parts are different. Five x cubed y is not a like term with 6xy cubed. These are not like terms because the variable parts are not the same. All right, what does it mean to simplify an algebraic expression? To simplify an algebraic expression, means to combine like terms. So to simplify algebraic expressions means that we need to combine any like terms that the expression may have in it. So let's try to do a couple. Let's try to simplify 2x plus 3x. Well, these are like terms because the variable parts are the same. And so 2x added to 3x is going to be equal to 2 plus 3 of those x's, or is going to be equal to 5x. We have just combined some like terms to simplify this algebraic expression. Let's try another one. Let's try to simplify this one. Negative 4x plus 5y plus 20x minus 14y. We want to simplify this algebraic expression. To do so, we have to combine like terms. Now, what is oftentimes helpful is to take your like terms and group them together inside separate parentheses. So I'm going to group together all my like terms of x. Negative 4x is a like term with 20x. Plus, and then I'm going to group together my other like terms of y. 5y is a like term with negative 14y. Now that we have like terms grouped together inside separate parentheses, it's easier to see how to combine them. What's a negative 4x added to 20x? Well, you can use a calculator in this class. The TI-34 Smart View is recommended. And so if I wanted to take negative 4x plus 20x, I need to know what negative 4 plus 20 is. Negative 4 plus 20. Let me show you on your calculator how we can dial that up. Negative 4 plus 20. So I'm going to go get my calculator. And I'm going to go get the TI-34 Smart View. This is a calculator that's recommended for our course. Although in reality, you can use any basic scientific calculator. If you are going to stay in this math business longer here at Washington or some other institution, you may want to invest in a graphing calculator, as those are required. So you don't have to use the TI-34 Smart View calculator. You could also use a nice model called the TI-30XS, which is just as capable and very similar to the TI-34 Smart View. So it really doesn't matter which one you use. I'm going to leave that up to you. But it has to be a scientific calculator. The nice thing about the TI-34 or TI-30 is that they can work very conveniently with fractions and mixed numbers. Okay. All right, so how would we take a -4 plus 20? Well, at the bottom of my keyboard here is my negative button. This is your subtraction button. So I'm going to type in a -4 plus 20. And that's going to give me 16. So -4 plus 20 is 16. So therefore, -4x added to 20x is going to be 16x. These like terms combine to give me 16x. 5y minus 14. Okay, what's 5 minus 14? Well, again, you're welcome to use your calculator to do that. So 5 subtract 14 would be equal to -9. And so 5y minus 14y is -9y. Notice we cannot subtract 9 from 16 because these are not like terms. This is as simplified as this expression is going to get. We are done with that problem. Okay, that's simplified. All right, let's try a problem from our textbook. Okay, on page 36, the practice exercises begin for section R4. I'm going to go down and do a problem here. Let's see if we can do number 45 here. They want us to simplify this algebraic expression by combining like terms. So I'm going to write that expression down on my paper. 4p squared minus 2p plus 3p minus 6 plus 2p squared. So this is the expression that we're going to try to simplify. Well, to simplify this algebraic expression, we have to combine like terms. 4p squared is a like term with this 2p squared over here. And again, feel free to group together like terms inside separate parentheses. So we got 4p squared plus 2p squared plus -2p is a like term with 3p. Those need to get together. We do have a constant term here, -6, that has nothing else to combine with, no other constant term to combine with, so we just bring it along. Okay, let's combine our like terms. 4p squared plus 2p squared combine to give us, what's 4 plus 2? 6p squared. A -2 plus a +3p, and again, you could do the -2 plus 3 on your calculator, would give you a +1p. And we got the -6. And we're done. This would be the simplification of this algebraic expression. We have combined all the like terms in it. You cannot combine any of these other terms because none of these are like terms. By the way, when you have 1 times a variable p, you can just call it p. So we could write this equivalently as 6p squared plus p minus 6. So again, if you have 1 times a variable or 1 in front of a variable, it's understood just to be that variable. 1 times p is understood to be 1p, which is just p. Okay. 1x, 1 times x is the same thing as 1x, which is just x. All right. So that algebraic expression has been simplified. Now, sometimes to simplify algebraic expressions, we're going to have parentheses in our expression. And I like to think of parentheses as being like a jail, and things inside the parentheses are kind of like in jail. And I'm going to show you how to bust things out of jail in mathematics, or bust things out of parentheses. To do that, I'm going to introduce you to what's called the distributive property, which is used all the time in algebra and beyond. It's called the distributive property. Okay, suppose I gave ourselves this numeric expression, and I wanted us to simplify or evaluate this numeric expression. It's understood it's 2 times 3 plus 5. Now, what would we do first? Well, there's a convention in mathematics called the order of operations that says we should do what's inside parentheses first before anything else. So we would add the 3 and the 5 together first to give us 8. And then the 8 would get multiplied by the 2. And so we would get 16. This expression would evaluate to 16. I can also show you on your calculator how we would type this in to evaluate it. 2 times quantity 3 plus 5. So on our calculator, how would we type that in? 2 times 3 plus 5. We would type in 2 multiplied by open parenthesis. This is called your open parenthesis. 3 plus 5, and then a closed parenthesis. For every open parenthesis you have, you should have a closed parenthesis. Hit enter, and you would get 16. You see, your calculator has been programmed to abide by the order of operations in mathematics. All right. You know, there's another way we could have got our answer of 16. It's called the distributive property. So another way we could have got 16 is we could have taken this factor of 2, and we could have multiplied it in or distributed into both these terms in here. So I can say 2 times 3 plus, and then I can take the 2 and multiply it by the 5. 2 times 3 is 6. 2 times 5 is 10. And then 6 plus 10 is 16. And we get the same answer. This is illustrating a very important property called the distributive property. In general, that property says if you have a number outside a set of parentheses, you can multiply that number into all the terms inside your parentheses. So A can get multiplied by B to give us AB, plus A can get multiplied by C to give us AC. This is illustrating the distributive property in mathematics. Notice when you distribute the A inside the parentheses, you remove your parentheses. So distribution always removes parentheses. I like to say by distributing the A inside the parentheses, we get the B and the C out of jail because the parentheses are gone. The jail is gone. Okay. Now, this distributive property is going to be useful when simplifying various algebraic expressions that have parentheses present. So let's see if we can simplify some algebraic expressions that have parentheses. In fact, let's go back to our textbook and see if we can find some. So at the end of section R4, here's some algebraic expressions that have some parentheses. Let's try to do problem number 55. They want us to simplify 8 times x minus 3 plus 1. I'll write that down on my paper. Okay, so we want to simplify this algebraic expression here. Now, to simplify this algebraic expression, okay, notice we do have some like terms or constants that have to be combined, but we have to get, first of all, this 3 out of jail. The only way you're going to get this 3 out of jail is to get rid of the parentheses. The only way you're going to get rid of the parentheses is to use your distributive property. we're going to have to take this 8 here and distribute it into both these terms. Now, 8 multiplied by 1x is 8x. Okay, plus, now we have 8 being multiplied by, you should view this as being a -3. 8 multiplied by a -3. And then we have the +1. Notice the 8 does not get multiplied by the 1 out here because the 1 is not inside the parentheses. The 8 only gets multiplied by all the terms inside the parentheses. By the way, what is 8 times a -3? Well, you can do this on your calculator. 8 multiplied by -3. Let's go do that. So we have 8 times a -3. You must hit your negative button at the bottom of your keyboard here, not your subtraction button, times a -3. And that's going to give you -24. All right, so 8 times a -3 is a -24. Now I can say plus a -24. But you know, plus a -24 is the same thing as just saying subtract 24. So that I could rewrite this equivalently as 8x minus 24 plus 1. Finally, we have some like terms that need to be combined, namely minus -24 and 1 need to be combined. So what is -24 plus 1? Well, again, you can go back to your calculator and dial that up. So what is -24 plus 1? It gives you -23. Okay, so -24 plus 1 is -23. And this would be your answer. Notice you cannot subtract 23 from 8 because these are not like terms. This is the simplification of that expression. To help us simplify this, we had to use the distributive property. Let's try another one that has parentheses. Let's go back to our textbook. All right, let's look at one like number 59 here. We have a negative sign in front of the parentheses that's containing 10w minus 1 plus 9 plus w. We need to simplify this algebraic or variable expression. I do see this like term of 10w that has to get combined with this w or 1w over here. But the problem is 10w is in jail. We have to get 10w and this minus 1 out of jail. The only way to do that is we're going to have to remove these parentheses. Now, we realize that we have a negative sign that precedes our parentheses. When that's the case, you should always think of this as being like a -1 that needs to be distributed inside the parentheses. So I'm going to distribute the -1 inside the parentheses. -1 times 10w. And you can do this on your calculator. -1 multiplied by 10 would be -10. So -10w. Now you're going to take a -1 and multiply it by, you should view this as being a -1 also. And a -1 multiplied by a -1 is a +1. Plus 9 plus 1w. Now we will combine like terms. I have like terms of w that need to get together. So -10w must be added to 9w. Excuse me, to 1w. Must be added to 1w. Sorry about that. So -10w must be added to 1w plus, and then we have some constant terms that need to be combined. 1 plus 9. Notice when I group together like terms in between the parentheses, I always put a plus sign, always. Now, what's a -10w added to 1w? Well, on your calculator, you can do -10 plus 1, and that would give you -9. So -10w plus 1w is -9w. And 1 plus 9 is plus 10. And we're done. This would be your answer. This would be the simplification of this algebraic expression. You cannot add 10 and -9 together because these are not like terms. All right, let's go back to our textbook and try another one. Let's try one like number 65 now. I'm going to write the problem down. Okay, so this is the problem we're going to try to simplify here. Notice we have JOs here and we have a JO here. We got to try to bust these things out of JO and get these things out of JO. The only way to do that is to remove these parentheses. The only way we remove parentheses is to use our distributive property. So I'm going to take the -3 and multiply it by -5. -3 times -5 is a positive 15. -3 then will get multiplied by 2W to give us -6W. Minus the 8W, just bring that down. Now we're going to distribute the 2 inside the parentheses here to get these out of JO. So 2 times 1W is going to give us 2W. 2 multiplied by a -1 is a -2. Notice all my parentheses are gone after using my distributive property. Now we have to combine like terms. So notice I have some constant terms that need to get together, 15 minus 2. And I got some W terms that need to get together. I have a -6W minus 8W plus 2W. All these need to get together. Now what's 15 subtract 2? That'll be 13. Okay, plus. Now -6W minus 8W plus 2W, and all need to be combined because they're like terms. To combine all these like terms, feel free on your calculator to type in -6 minus 8 plus 2. -6 minus 8 plus 2. Let's go to our calculator and do that. Okay, so we're going to type in -6 subtract 8 plus 2. All those numbers combine to give you -12. Therefore, -6W subtract 8W plus 2W is -12W. Now, instead of saying 13 plus a -12W, this is equivalent to as if I just say 13 minus 12W, same thing. Notice you cannot subtract 12 from 13, so we would stop right here. This is the simplification of this algebraic expression. And that's how we simplify algebraic expressions, by combining like terms. And there will be times when we may have to use our distributive property to get terms out of JO, so to speak, so that then they are freed up to be combined with other like terms in the expression. Okay, section 1.1, now we'll turn our attention to solving what are called first degree or linear equations. What is an equation in mathematics? Well, in general, a linear equation is going to be a construct that looks like this. X is the variable, A, B, and C are just numbers. Okay, these are called equations, no longer algebraic expressions, because we see the equal sign that's involved in our situation. These are called equations. We're going to learn how to solve equations. Let's give ourselves a basic equation to look at. This is called a linear equation, and our job is to try to figure out, okay, what numeric value we would have to replace X with so that we would have a true statement here. Well, what number has to be added to 2 to give us 5? Well, after a little thought, we would realize that 3 is that number. So the solution to this equation better be x must be equal to 3. But let's show you formally how we would actually solve this equation here for x, or for the unknown, or for the variable. All right, in order to solve an equation, our goal is always to get the variable all by itself on one side of our equation. This is called the left side of the equation. This is called the right side. We need to get the x all by itself on the left side of the equation. We need to get rid of this 2 that's being added to x. What's the inverse of addition? Well, subtraction is the inverse of addition. And so in order to make this plus 2 go away to get the x by itself on the left side of our equation, we're going to have to subtract 2 from the left side of our equation. But you know what? If I subtract some number from the left side of my equation, I must also subtract the same number from the right side of my equation to maintain equivalence. Think of this equal sign as being like a balance or a pivot point. If I subtract 2 from the left, I've upset the balance. To right the ship, I must also subtract 2 from the right side of my equation. Now the 2's on the left side of the equation add up to 0. 2 minus 2 is 0. Or we say the 2's just cancel out. They're gone. And it leaves you with just x. And on the right side will be our solution. 5 subtract 2 is 3. We're done. This is called your solution to that equation. You can always check your answer when you solve an equation. So to check my answer, I will take 3 and I will substitute 3 back into the original equation for the variable x. 3 will go back in here. And let's see if it checks out or if it works. Is 3 plus 2 equal to 5? And it looks like it works. It checks out. So 3 is indeed the solution and the only solution to this linear equation. We have just solved a linear equation. Let's try another one. Notice the instructions will say not simplify, because these are not just expressions anymore. These are not just algebraic expressions, they're equations, and we always solve equations. Let's try to solve this equation for the variable t. So to solve this equation for the variable t, we have to get the variable t all by itself on the left side of our equation, meaning we have to get rid of this 4 that's being subtracted from t. Well, what's the inverse of subtraction? Well, the inverse of subtraction is addition. So to make this 4 go away, to get t all by itself on the left side of our equation, we're going to have to add 4 to the left side. But if I add 4 to the left side of my equation, I must also add 4 to the right side of my equation to maintain equivalence. The 4's on the left side add up to 0 or cancel out, leaving you with your variable t all by itself. And on the right side, we have negative 12 plus 4, which you could type this into your calculator. Negative 12 plus 4 gives you negative 8. And that would be your solution to your equation. T has to be equal to negative 8 for this to be a true statement. And you can check your answer even visually if you want. If you put negative 8 back in here, is negative 8 subtract 4 equal to negative 12? And I think you'll discover that that is the case. Negative 8 subtract 4 is equal to negative 12. That's why we call negative 8 the solution to that equation. All right, now I want to give you this type of look here. Let's try to solve this equation for the variable n. Notice we need to get n all by itself on the left side of our equation, which means we have to get rid of this 10. But notice the sign that's in front of the 10, it's a negative. In order to make a negative or a minus go away, we have to add. Addition is the inverse of minusing or subtraction or a negative. So to make this negative 10 go away to get n by itself, we're going to have to add 10 to the left side of our equation. But if I add 10 to the left side, I must also add 10 to the right side of my equation to maintain equivalence. The 10s drop out on the left side of the equation or add up to 0, or we say just cancel out, leaving you with your n all by its lonesome. And 14 plus 10 on the right side of our equation is our solution to our equation. N must be equal to 24. That is your answer. That's your solution to this linear equation. All right, let's now begin to show ourselves how to solve some equations that involve division or multiplication. We want to solve this equation, this linear equation, for y. We need to get y by itself. Well, presently, that's not the case because we got the 5 on the left side along with the y. In order to get rid of this 5, we need to understand what operation 5 and y are involved in. Well, it's understood that it's 5 times y. So what's the inverse of multiplication? That would be division. In order to get y by itself on the left side of the equation, we're going to divide the left side of our equation by the 5, the thing we want to get rid of. But if I divide the left side of my equation by 5, I must also divide the right side of my equation by the same number to maintain equivalence. Now these 5s on the left side of the equation reduce down to 1. And 1 times y is better known as just y. Now what's a negative 20 divided by 5? Well, you can dial that up on your calculator. Go try that. Negative 20 divided by 5, you'll discover you get negative 4. So y is equal to negative 4, and that would be our solution to our equation. Okay, let's try this one here. Let's try to solve this equation. 3/4 is equal to negative 1/2 times b. We will try to solve this linear equation for the variable b. Now we got to get b all by itself on the right side of our equation. In order to do that, we have to get rid of this negative 1/2. That is being multiplied by b. It's understood it's negative 1/2 times b. The inverse of multiplication is division. So in order to get b all by itself on the right side of my equation, in other words, to solve this equation, I have to divide both sides by a negative 1/2. So we'll have to divide the left side of our equation by negative 1/2. And we have to divide the right side of our equation by negative 1/2. The negative 1/2s on the right side of the equation reduce to 1. And 1 times b is better known as b. Now on the left side of our equation, we're having to deal with dividing 3/4 by a negative 1/2. Well, how do we do that? Well, we have a nice calculator in the TI-30 or the TI-34 that can deal with fractions very easily. Let's go back to our calculator to show ourselves how we can divide 3/4 by negative 1/2. To divide 3/4 by negative 1/2, first I would hit my fraction button, my fraction template button, which is this button right here, n over d. Now I can type in the fraction 3/4. Then I'm going to say divided by, open parenthesis, negative 1/2. There's the negative sign. Now I'm going to hit my fraction button again and type in the fraction 1/2. Closed print. Whoops, you gotta bring your cursor back up to level. And so you have to hit your right arrow key to bring it from the denominator back up to the main level. Now you type in your closed parenthesis. Now we just hit enter and we'll have our answer. Now your answer is reported as a mixed number. You can always go back and forth between a mixed number and a fraction. On your calculator, above your mixed number template button, that affords us the ability to go between a mixed number and a fraction. So if you don't want to leave your answer as a mixed number, negative 1 2/4, you can go back and turn it into its equivalent improper fraction. by hitting your second button, followed by your mixed number button. This will convert it back into its equivalent improper fractional form, -6/4. Now on the TI-34, if you want to reduce this fraction, you just hit your simplify button, SIMP. That'll simplify this fraction down or reduce it down to -1.5, which you can convert back into its equivalent improper fractional form by hitting your second button and then your mixed number button, and you get -3/2. Okay. This would work the same way on your TI-30X calculator. On your TI-30X calculator, you would hit your fraction button, 3/4, divided by, I like to enclose my negative numbers inside parentheses for clarity, -1/2 okay, and then just hit enter, and you get -3/2 there. Nice thing about the TI-30XS I've noticed versus the TI-34 multi-view is that the TI-30XS, okay, cuts through the chase and reduces your fractions down immediately. Where with the TI-34, you may have to use the simplify button that I illustrated. So actually the TI-30XS is a little bit more efficient than the TI-34 multi-view. All right, so therefore 3/4 divided by -1/2 turns out to be -3/2. And that would be your solution to this equation. Okay, let's try to solve this linear equation now. Suppose I have the variable x divided by -3 equal to 17, and I want to solve this equation for x. Now, notice our variable is being divided by -3. In order to get x all by itself on the left side of my equation, I have to get rid of this -3. But how do we do that? Well, what's the inverse of division? That would be multiplication. So in order to get x all by itself on the left side of my equation, I'm going to have to multiply the left side of my equation by x over -3. Excuse me, I'm going to have to multiply the left side of my equation by -3. This -3 is understood to be over 1. Well, I have to multiply the right side of my equation by the same number, by -3, to maintain equivalence. Notice on the left side, when I multiply these together, I'll have -3x over -3. And on the right side, -3 times 17 is going to give me -51. Notice the -3's here reduce to 1, and 1 times x is better known as x. So the solution to this equation is -51. That would be your solution. Let's try another one here. Let's try to solve this equation for w. Well, to solve for w, we would like to get w all by itself on the right side of this equation. To do that, we have to get rid of the 5. We need to realize that w is being divided by 5. The inverse of division is multiplication. So to get w by itself on the right side of the equation, I would have to multiply the right side by 5, or by 5 over 1. Notice I'm using a dot operator for multiplication so that we don't confuse it with the traditional multiplication symbol from basic math, which could be confused for the variable x. So instead of saying 2 times 3 this way, because we're in algebra now and we're dealing with variables, we use the dot operator for multiplication to avoid this possible confusion with the variable x. Okay, but we got to multiply the left side of our equation by 5 also. This is saying 5 times -11. It's implying that. The right side of our equation, the 5's basically reduce out to 1's, leaving us with w, or 1w. And 5 multiplied by -11 gives us our solution of -55. And that would be our answer to that equation. So far, our equations have required only one step to solve them, but in reality, there's more advanced equations that require several steps. I'm going to now show you an equation that involves 2 steps to solve for the variable. We will try to solve this equation for the variable c here. In order to solve this equation for the variable c, I need to get this variable c all by itself on the left side of my equation. So how do we do that? Well, in order to accomplish that, we're going to have to get rid of the 14 and also the -2. So which do we do first? Well, the order of operations say we do multiplication before subtraction. However, when we're solving equations, we turn the order of operations upside down. The first thing we need to do is ask ourselves, can I simplify both sides of my equation here? Well, it looks like the left side is already simplified. There's no need to combine like terms, and the right side is already simplified. So now it's time to separate the variable terms on one side of my equation versus the constant terms on the opposite side. So what I'm going to do is I'm going to move this constant term of -14 over to the right side of my equation. But how do you move a negative to the other side of the equation? What's the inverse of subtraction? That would be addition. So the first thing I'm going to do is I'm going to add 14 to the left side and to the right side of my equation. The 14s drop out on the left side to 0 or cancel out, leaving us with -2c. And on the right side, we have 2 plus 14, which is 16. One last step now to solving this equation. Now that we have the variable terms on the left side and the constant terms on the opposite side of our equation, we now just have to finish this problem by getting the variable all by itself on the left side. To get c all by itself, we need to get rid of this -2 that's being multiplied by c. The inverse multiplication, again, is division. So we divide the left side of our equation by -2, but then we also have to divide the right side of our equation by -2. The -2's on the left side of the equation reduce down to +1, and 1 times c is c. And with 16 divided by -2, you'll discover that it's -8. And that is your solution to this equation. This equation required 2 steps to solve. Okay. Let's see if we can go get another 2-step equation from our textbook. For section 1.1. Well, I think I got timed out here. So I'll make one up here. And so let's see if we want to solve this one here. Okay, suppose we want to solve this equation for the variable t. In order to solve this equation for the variable t, we got to get t all by itself on the right side of our equation. And so how are we going to do that? Well, notice there's no need to simplify the left or the right side of your equation. And so therefore, it's time to separate the constant terms on one side of our equation from the variable terms on the opposite side. I'm going to move this +7 over to the left side of my equation by subtracting 7 from both sides. Now, -20 subtract 7 is going to give you -27. The 7's drop out on the right side of the equation to 0, leaving you with 9t. To solve for t now, I have to get rid of this 9 that's being multiplied by t. So the inverse of multiplication is division. So I divide both sides of my equation by 9. -27 divided by 9 is -3. These 9's reduce down to 1 on the right side, and this would be your solution to that equation. And we're done with that problem there. Okay. Sometimes there will be need to simplify one end or both sides of our equation before we actually can start moving things from one side of our equation to the other. So in other words, if I had like 5x if I had this equation here to solve for x, first of all, I would have to do a little simplifying on the left side of my equation. I have to combine some like terms. First, to do that, I have to get rid of the parentheses. So I have to use my distributive property. And I indicated earlier, when you got a minus sign that precedes parentheses, it's really like a -1 that needs to be distributed in. So therefore, we'd have 5x, -1 times 2x is minus 2x. -1 multiplied by 6 is minus 6. Combining like terms on the left side of our equation, 5x minus 2x combined to give you 3x. Now that the left side is completely simplified, it's time to begin to separate the variable terms on one side of your equation from the constant terms on the opposite side. I'm going to move the 6 over to the right side to join the 18. The way we do this legally algebraically is we have to add 6 to both sides. In which case my equation now becomes 3x equal to 24. Finally, to solve for x, we have to get rid of this 3 that's being multiplied by x by dividing both sides of our equation by 3. And we get 8 as being our solution to this equation, and we're done. So sometimes you may have to simplify one and or both sides of your equation by maybe distributing or combining like terms. So far, our variable has only been on one side of the equation. What if we have it on both sides? Suppose I want to solve this equation for x. Notice we have a variable x appearing on both sides of our equation. Well, first of all, we ask ourselves, can we simplify the left side in any way? Is there any need to distribute or combine like terms? The answer is no. The left side is already simplified. The right side, can it be simplified in any way? The answer is no, it's already simplified. So now we're going to try to separate the variable terms on one side of our equation versus the constants on the opposite side. My personal preference is to bring the variable over to the left side of the equation always. So I'm going to move this 2x over to the left side of the equation to join the 16x. We need to, in order to do that, we need to realize that we have a plus sign that precedes the 2x, understood. How do you get rid of plus? You subtract. So we have to subtract 2x from both sides. By subtracting 2x from both sides, this effectively moves the 2x over to the left side of your equation. 16x minus 2x, as we combine these like terms, gives us 14x. 2x minus 2x on the right side of the equation, these 2x's cancel out, leaving you with -18. And now we're back to a familiar equation. Continuing to separate, I need to move this constant 10 over to the right side to join the constant -18. To accomplish that legally algebraically, I subtract 10 from both sides. The 10s on the left side cancel out to 0, leaving you with 14x. -18 subtract 10, you could do that on your calculator, would give you -28. Finally, to solve for x, I divide both sides of my equation by 14 to get x all by itself. These 14s on the left side of my equation reduce down to 1s, leaving with 1x or just x. And a -28 divided by 14 is -2, and that would be your solution to this equation. X must be equal to -2, and we're done. Okay, so what we've seen in section R4 here and 1.1 is, first of all, in R4, we simplified algebraic expressions by combining like terms. And in section 1.1, we then turned our attention to solving linear equations for the variable. Hopefully this helps you out.